Well, there's no single answer to that question, and everyone has different evaluation criteria, but Solo has worked with dozens of enterprises who are wrestling with this same question, and we've noticed some helpful trends in the kinds of questions they ask that really get at the important differences between alternative solutions. So let's take a look at a few of those questions. Number one, what platform is the gateway built on? Does it come from a single vendor, or is it open source and supported by a world-class community? This is a critical question. No one wants to be locked into a single vendor, but many API gateway solutions are based either entirely on closed source implementations, or they're based on open source platforms that have essentially a single vendor driving them. Neither of these is a solid foundation for your API gateway strategy. Solo's Gloo Edge is based on the open source Envoy platform, and Solo is one of the leading contributors to that platform, along with other technology leaders like Google and Amazon and Lyft. So not only is Envoy open source, but there's also an enthusiastic community of tech leaders who are behind it. Another question we often hear is, how is the platform architected? Is it cloud native from the ground up, or is it perhaps based on some old style monolithic architecture that forces you to configure extra moving parts like an external database? Gloo Edge is cloud native from the ground up. The control plane is deployed as a fleet of Kubernetes microservices within your cluster. Its constructs are all expressed as Kubernetes custom resources, and its configuration objects are all stored in the native etcd storage system. No external database is required. So if your developers are already comfortable in Kubernetes, they're going to feel right at home with Gloo Edge. Another question we hear is this. So you have a cloud native architecture, but does that architecture allow you to scale efficiently? Does it allow you to separate data and control planes from each other, allowing a single control plane to manage multiple proxies? Or does it add complexity by forcing your deployments to drag along the control plane with every single data plane deployment? That really becomes an important question when you're talking about scaling out systems. Gloo Edge is based on a foundational premise that the control plane and data plane of your API gateway must be separable. You must be able to scale them independently of one another so that you can have one or a small number of control plane instances controlling a whole fleet of data plane proxies. Otherwise, large-scale distributed deployments become nearly impossible. Another question we get frequently is, how do you extend the platform? What do we do when we can't solve a problem with just out-of-the-box features? Well, that's a great question because many API gateway solutions are proprietary and offer few options for customer-specific extensions. And even some of the ones that offer extension support are based on obsolete, seldom used scripting languages that have little or no community support. On the other hand, with Gloo Edge, you can build custom filters based on the emerging WebAssembly standard. WASM has been used to execute sandboxed code within web browsers for years now, and its popularity is now growing in reverse proxy environments as well. So rather than being restricted to a single, seldom used language, Solo offers runtime environments for WASM that covers a broad spectrum of popular languages. Languages like AssemblyScript, C++, Rust, and TinyGo. Solo has also shown its commitment to the WASM community by publishing WebAssemblyHub.io, a free community website to store and manage WASM images.